So, we've been looking at circles, okay? And, you know, what's one place that we see circles all the time? Well, one place I see them is on...
Pizza.
Pizza, yes. What's your favorite pizza flavor?
Meat lovers.
Who else loves meat lovers?
Barbecue chicken.
Why do you like meat lovers, Riley?
Because it has meat on it.
It has meat on it. Does anyone have something different? Something different? Share it with the class for us. Trinity, go. Listen up. Sorry? Hawaii. Okay. Who likes pineapple on pizza? Okay, come first. Who likes pineapple? All right. Okay. So we've been looking at circles, but we can also look at parts of circles. On your sheet there, you have different parts of circles. So for example, if I took a piece of pizza and I wanted to cut it up and share it with people, if I took my pizza like this, right, here's my circle, and if it's got some funny edges there. Let's cut it this way. How much of a circle do I have there?
1 out of 2.
Go, Max.
You have 2 halves.
I've got 2 halves, so I could say how much of a circle or how much of a pizza I've got half here, right? That's fair enough. What if now, let's take one of these halves. What if I cut them again? Now, what would I have? What would I have here? I've got a 1/4. How do I write that as a fraction? As 1/4. All right, brilliant. Now, what if I take this? I'm going to take this half again. I'm going to cut it up. Now, if I have, they are quite large slices. If I take this here, right? Just listening. If I take this, and let's say, you know, I'm feeling pretty hungry. I want to take.
Holy moly.
I want to take all of this. How much of a pizza do I have here? Yeah. Sorry? What did you say? 1/4. So we've got, each of these is a quarter, right? But if I take 3 of these pieces, how many am I going to have? How much of a pizza do I have now? How much of a pizza do I have? Have a think carefully. Go, Bianca. 3/4, right? And it's really great to see it visually because you can see, oh, I've got 1 slice here. One of these is a quarter, as you said earlier. But if I take 3 of these, now I have 3/4. We can see those quite nicely. It becomes a little tricky though when I do something like this. Let's say I'm a bit more specific. I want to take a pizza, again. We'll take another pizza. Take this guy. And if I take this and I say, all right, I don't want 3/4 of pizza. I don't want 1/4. I don't want half. I actually want this. I want a piece of pizza where when you cut it, right, I create this angle here. 240 degrees. It's very specific, isn't it? I bring out my protractor, I come into the dinner party and say, all right, I want exactly 240 degrees at the center. Now, how much of a pizza do I have? Have a think carefully. What do you think, Marissa? 2/3. 2/3. Would you agree, Liz? Why do you agree, Liz?
Well, because 240 over 360 applies to 2.
Okay, so let's come back to how did we actually work out these were halves and quarters and all these slices? We were thinking about fractions. We didn't have to know anything about angles in order to do this. But we do know that in a whole circle, we have 360 degrees. And so really, if you're thinking about how much of a circle you have, in fact, these slices that we've created, mathematically, we call these sectors. Okay, these are sectors, all right? You can think about how much they have when it's a strange cut like this by taking, all right, in a whole circle, we have 360 degrees. So how much of a circle do I have here? If I only want this section that's shaded in, right, well, then I'm going to take, all right, 240 all divided by 360. Because 240 is the angle that I've created here. This is the slice that I want. And then what's the whole amount? As you said, it was 360. When you put that in your calculator, you can simplify it. It does become 2/3. Okay? That's what we're learning about today. We're going to look at finding the areas of sectors. So we've got that the whole area of a circle is 360 degrees. To find the area of a sector now, it's going to depend on what? What is it dependent on? If we've got these various slices and sectors, what's it really dependent on if I'm thinking about how large this slice is? What do I need to consider?
How much you want to find the area of.
How much I want to find the area of, yeah? That's true.
Fraction of the area.
What fraction of the area? Yeah, true. Okay, so let's come back to this one. Let's just check that this works, right? For a quarter, what's the angle created here? It's a right angle, yeah, which is 90 degrees. That's 90 degrees there. And let's just check that this is a quarter. I've got 90 over 360. Can you just put that in your calculator for me to check? It's right. Okay, brilliant. So this is 1 over 4. So this theory tests out now. So all we need to do to find the area of any sector, right, we just need to consider the angle which is created from the center. Okay? So I can take any sector now. And this is why in mathematics you want to generalize things, because you won't always get specific situations. So can you write this down for me? To find the area of any sector, of angle-sized. Now, when we're talking about unknown angles, we actually use a particular symbol. I'm not sure if you guys have seen this before, but if you take, let's take, this is my sector here, all right? That looks a bit too much like a right angle. Let's take this one. There we go, that's a bit better. I'll try one more time. I think I can do a bit better than that. Okay, there, much better. Now, if I take an angle, we usually use this symbol here. Has anyone seen this symbol before? It's a funny little symbol. It's a Greek symbol, and just like you would use X for unknown numbers, right? They love to use this symbol for unknown angles. It looks like it. So I should actually complete it. It's actually a circle with a kind of a line through it, but the line's a little bit curved. So you can try to draw that for me, okay? This is pronounced theta. And it's a Greek letter. You might have seen that before in some places, right? Theta, yeah. It's called theta, and we use it specifically for unknown angles. Just like we use X for unknown numbers, we use this for unknown angles. So, I'll find the area of any size, any sector of any angle size theta, right? What we need to do is this, right? We need to think how much of a circle that we have. And we know how to express that. We express that by taking the angle at the center and dividing it by 360. So the power of this is I can say, all right, instead of writing any angle, I can use this symbol here. I can say, well, the formula would be, or for the area would be theta over 360. That's how much of a circle I have. But to actually find its area, what else do I need to consider? I've got how much of a circle I have now. For example, I've got 180 over 360. That's half of a circle. But if I want to find its area, what's the expression that we use for that? We developed a formula to help us find the areas of circles. What was that? Does anyone remember that one? Go, Isaac.
Can you stand up and apologize?
Pi times r to the power 2, or we can write that as pi r squared. So the area is going to be theta over 360 times pi r squared. Can you write that down for me? Theta over 360 times pi r squared. Any questions on that one?